Welcome back. Don't forget to like, subscribe, and drop your comments. Like I said as well, displacement is a vector quantity. Velocity is a vector quantity. Speed, do you consider speed a vector quantity or a scalar quantity? Time will tell. Now, in the case of velocity, the SI unit of velocity is meter per second, or mx minus 1. The SI unit of velocity is meter per second. We quickly want to push ourselves down to acceleration. From the diagram you have there, you see a moving car. And there is also telling us that it has got to do with acceleration because the car has virtually changed its speed. Assuming you have a moving car, moving from point A to point B. This is point A to point B. We shall make use of two parameters. But before we talk about that, let's change what we have here on velocity and move it down to acceleration. Acceleration, very fastly, is the rate of change of velocity per unit time. So, acceleration is represented with an A. It's equals to V minus U over P. Now, let's deal with the parameters here. Acceleration is represented this way. A is equals to acceleration. V is equals to the final velocity. U is equals to initial velocity. Don't forget that T is equals to time. So in a case of this nature, the final velocity is, assuming it's 10, and initial velocity is 5. You can see that the car is making progress. As it moves down from point A to point B, it goes down in this form. And so it's very clear that it has progressed from 5 to 10. So that means acceleration is the rate of change of velocity per unit time. And that's why we have an indication of something of this nature. Sometimes it could be referred to as A is equals to the rate of change of V over T, or rate of change of V over rate of change of T. That will give you your final acceleration. We want to quickly take some solved example on speed, velocity, and acceleration very fastly. We quickly want to take an example 1. A motorist travels from a town A, 150 kilometers in 2 hours, 45 minutes. We are asked to find its average speed. A in kilometer per hour and B in meter per second. So, firstly, we want to quickly solve that has got to do with kilometer per hour. So, A, solution. Step A. What do? Locate the parameters. Our distance, remember that distance is measured in meter. But we want our answer, our question here is kilometer per hour. So first of all, work in kilometer and subsequently work in meter per second. So step A, locating the parameters. We have that the distance is equal to 150 kilometers. Don't forget that the time here is 2 hours, 45 minutes. So we're asked to find the average speed. So speed is equal to distance over time. Step 1, locate the parameters. What are the parameters? Step 2, what is the formula we'll be using here? And then step 3, We'll copy it into the formula. So, we'll move this way. Don't forget that our D is 150, and our time is 2 hours 45 minutes. So we'll be having 150 over 2 multiplied by 45 over 60. So we'll be having 15 here, we go 3 times. And 15 here, we go 4. So we will be having 150 divided by 2 times 3 is 6. So we'll be having 6 over 4. So we'll be having 150 divided by 6 over 4. So we have 150 multiplied by, this man is coming up here, 4 over 6. So 2 can go. 2 into 4 is 2, and 2 into 6 is 3. We can still divide. We don't need calculator. 150 multiplied by 2 over 3. Something can still go. 3 can go. So 3 going to itself is 1. And 3 go into 15 is 5. 3 into 0 is 0. So 50 multiplied by 2 will give us 100 kilometers. That's the final answer. Having said that, we quickly want to come in solve for meter per second, because all this lot we've just done was for kilometer. We want to now do that of meter per second. Solving in meter per second. Don't forget our final answer here is 100 kilometers per hour. So, for meter per second, we already have that distance is 150 kilometers. We have our time as 2 hours 45 minutes. So solution here is still in the same dimension of solving in distance over time, but there's a slight difference. In this angle, we already have speed is equal to distance over time. That's our first step. The parameter stated there, that is, the first step. The second step, inscribing these parameters into this. But first of all, there's something we need to know. We need to convert from kilometer to meter. What do? Don't forget that 1 kilometer is equivalent to 1,000. And we need to convert from hour to minutes. So we are going to multiply 60 times 60. So we will be having 1,000 all over 60 times 60. You get that? Now, what do? For this kilometer, we're going to do something to it. We multiply 150 multiplied by 1,000 all over 60 times 60. So let's start cancelling out fast. We'll use the blue pen to make it better, so you understand our direction this time. So 0, we cancel 0. 0, we cancel 0. To make it more clarified, we'll write out this to make it properly defined. So we'll have 15 multiplied by 100 over 6 times 6 is 36. So something can go, 3 can go. 3 into this will give you 12, because 3 into 3 is 1, 3 into 6 is 2. 3 into 15 will give you a 5. So what do we have? We'll multiply at this junction. So we'll be having 500 over 12. because 5 times 100 is 500. And then this 12, bring it up here. Now, we have speed is equal to distance over time. So here, we have distance. This whole thing we calculated here represents the distance. So that will be 500 over 12 over. Remember, we had 2 hours, 45 minutes. And we had 6 over 4 here. So we'll be putting 6 over 4 as the time after the conversion. So we will be having 500 over 12 multiplied by 4 is coming up, and we have 6. But if you like, you can cancel out. But if you don't like, you can do it the way I did. So 4 here, 1, 4 into 12 will give you a 3. So you will be having 500 over 18. At this junction, you can use your calculator if you like. But if not, you can solve outside the box by doing it in your own way. But if you're very fast with your calculator, you'll be arriving at 27.18 meter per second. Kudos to as many that got those answers very correctly. In summary, we differentiated between speed, velocity, and acceleration. We also talked about speed as the distance traveled per unit time. We also talked about speed. The unit of speed is the meter. Velocity is the distance per unit time, or speed rather, per unit traveled per unit time. We talked about the unit of velocity as meter per second. We talked about acceleration as well, and talked about acceleration as the rate of change of velocity per unit time. Distance traveled in a specified direction per unit time. So that is the change involved in acceleration. We concluded by solving related examples. Okay? Don't forget that the formula for speed is equal to distance over time. Don't forget that velocity is also speed over time. Don't forget that acceleration is equal to v minus u over t, where we stated that A is equal to acceleration. We stated that v is equal to final velocity. We also stated that u is equal to the initial velocity. And we didn't fail to say that t is equal to time. Those were some of the summaries being stated. We have some assignment that we flash through on the screen very fastly. And then I want to say thank you to you for your time. You just made my day.